STEM top grades, be exam ready, achieve top grades. Trigonometry Part 2, the Grade 7 to 9 Challenge. Part 2, Exam Style Practice. Here we're going to be looking at bearings, 3D shapes, elevation and depression, and finally, mixed methods. Learning objectives for this session. By the end of this lesson, you will be able to apply bearings. This means you'll use trigonometry to solve bearing problems, including back bearings and multi-leg journeys. Then you're also going to be solving problems in 3D. Here we are going to be identifying right angle triangles within cuboids, pyramids, and prisms to find lengths and angles. Thirdly, we're going to be using concepts of elevation and depression. So we are setting up and solving real-life problems involving angles of elevation and depression. Fourthly, we're going to apply mixed methods. What that means is we're going to decide between SOHCAHTOA, the sine rule, and the cosine rule within multi-part questions. And finally, we'll get the opportunity to combine techniques. Here, we are sequencing two trigonometric methods to solve extended exam style problems. Concept number 1, trigonometric bearings. This is your examiner tip. Draw a diagram every time, mark north lines at each point, and measure bearings clockwise from north. Our first question states the following. A ship sails from port P on a bearing of 070 degrees for 40 kilometers to point A. Find how far north of P point A is to 3 significant figures, and thus for 3 marks. So let's decide where we're going to place A. So place point A is going to be somewhere, that's going to be point P to start off. And we are going to draw a north line from P. And from that north line, we're going to draw roughly an angle of 70 degrees. Let's say that is our 70-degree angle. And that reaches A. At A, we're going to draw another north line. And that point A is 40 kilometers from P. And the question says you're going to find a distance from P going north. Okay, so how far north? That's the question. How far north? So let us say this is that distance. So we're going to label that Q, and that red line is representing that length we are to calculate. How far north? P. So that means PQ. And therefore, we're going to help explaining our work by drawing the line QA, which makes a right-angled triangle, and that allows us to apply the formula SOHCAHTOA and decide beforehand which of the 3 formulas SOHCAHTOA will be applied in that case. Now, if you have an angle of 70, so therefore the side opposite 70 will be obviously the opposite, and the side which is adjacent to 70 is therefore our adjacent, and that is going to be our hypotenuse. So we do not have any information about the opposite. So we do not have any information about the opposite. That therefore tells us we are going to be looking for the adjacent. So that formula that we're going to be using is K, and adjacent. So adjacent is equal to hypotenuse multiplied by cos. In fact, so this is length PQ. So hypotenuse is 40. So multiplied by cos of 70 degrees. So 40 times cos of 70 is going to give us 13.7 kilometers, and the answer is given to three significant figures. There we go. Now in question 2, a boat sails 25 kilometers from port on a bearing of 205. Now just as a reminder, so we are measuring clockwise from north. So that's a 0 degree, that's 90 degrees, that's 180, and that's 270 degrees, and finally you got 360 degrees. That's a full circle on a bearing for any point. Now 205 will be somewhere in this area. So let's draw our north line. So let's call that a point, the point. It can be just labeled as a point P, and on a bearing of 205. So that's 205, and that is 25 kilometers from point P, and let's say it goes to point Q, and all that angle is 205. So 205 is in that arc over here. So 205. Now what we are looking for is how far west. Now that length can be either placed here or here. So let us see 205. So if we want to find this angle, so let us work out what happens then. So let's call that angle theta. Okay, so angle theta would be 205 take away 180. All right, so 180 minus that's taking away 180, so that is 5, and that gives us 25. Now if that angle is 25 degrees, we're looking for the opposite. That's how far west it is. So the opposite, we got the hypotenuse. So if you wish to write SOHCAHTOA, okay, we definitely have no information about the adjacent. So adjacent, let's remove the adjacent from this. Let's remove the adjacent from this. So in the end, we're looking for sine, the sine one. So okay, so we're looking for the opposite. So all we got to do is multiply the hypotenuse. So opposite is the hypotenuse multiplied by sine, and therefore the distance. Okay, so let's call that r. So distance QR, which is how far west from P. That means hypotenuse is 25, and then multiplied by the sine of the angle, which is 25 degrees. Okay, 25 sine 25, that gives us 10.6 kilometers, and that's distance the western side going west. Okay, so I hope you have picked up some ideas here. Now we're going to try to see if you can apply them in those three questions that follow. I will see you on the other side with the answers there, so you can pause and try these questions now. Here we are. These are the answers for the three questions which I have set you to do as practice, and you will see all the answers there, and hopefully you'll be able to understand what I've written down and be able to learn a little bit more in terms of how you should present your work. Structure is really important. Okay, moving on now to the next concept, concept number 2. Here we're looking at trigonometry in 3D. So examiners, what they want you to know is that you have to redraw the right angle triangle you need as a flat 2D diagram taken from inside the 3D. It is far easier to work with the triangle once isolated. Okay, So we're going to make an attempt at drawing 3D shapes here. Let us see how that works. So we got a cuboid. Now, in order to draw a cuboid, we can have, so let's say we're going to start from here. So we draw two faces like this, identical, and then just connect them. There you go, done. So cuboid has length 8 centimeters and the width is 6 centimeters and the height is 5 centimeters. So the question says find the length of the diagonal AG. Now, right, it says AG here, but okay, let's call that AG. That's the full length across that corner to the other corner. Now, in what you need to remember that in 3D shapes, 3D is actually 3D Pythagoras. So I'm going to make a note for you here. So 3D Pythagoras. So we're going to do one triangle at a time. So we're going to have two triangles to deal with. Okay. Now, so one triangle is, I'm going to color code this for you. So we're looking at a triangle that way. So then we're going to use one of the sides, which is this one, the blue one, and then use the blue triangle. Now, because you've seen the triangles that we are going to deal with, now I think you can understand why I'm going to label certain vertices. So let's call that A, B, C. That's for the red triangles. And then for the blue triangle, we got A, C, G. So two different triangles. So let's move on to the red triangle, okay? So, and therefore you're going to provide structure in your answer as well. So we're going to mention triangle ABC. Now, what I'm telling you, what I'm showing you is the method that you got to follow. Sometimes we do have shortcuts, but I'm going to show you the full method before I show you the shortcut. Okay. So let's look at the full method first. So A, B, C. So we got AC, which is found by using Pythagoras theorem. So AC squared, AC is the hypotenuse for 6 and 8. So we are having AB squared. It's always good to write an expression or an equation as formula. This is your formula to use. So AC squared is AB. AB is 6, so square 6. BC is 8, so we're going to square 8, and therefore AC is the square root of 6 squared plus 8 squared. Now, for those people who know the Pythagorean triplet, so if you got 3, 4, 5, now you can see here you got 6, so everything is multiplied by 2, multiplied by 2, multiplied by 2. So I know the answer is going to be 10. But I've got to show the method. Okay, so 636, that's going to be 64, and that's going to give me square root of 100, and that gives me 10. The unit is 10 centimeters, so that's going to be 10 centimeters long. And now I'm going to be using the second triangle, which is the blue triangle. So I'm going to use this color. So triangle AGC. So in triangle AGC, now I'm looking for, well, you got this is 8 centimeters already given. Sorry, it's not 8, it's actually 5. So I'm just going to tidy up. I'm going to write 5 in that case. So 5 centimeters. Now we got a triangle. Now you will remember that it says redraw the triangle. Sometimes also one triangle taken from the drawing. And I'm going to copy this triangle. Okay, so we got 10 centimeters, 5 centimeters, and then you got A, G, and C. In that case, we're looking for AG, and therefore using Pythagoras theorem, we're going to have to start with AG squared first. AG squared is the hypotenuse for the other side. So AC squared plus CG squared, that gives me 10 squared plus 5 squared, okay? And AG is going to be the square root of all that. So that's going to be 125 square root. And that is going to give me, we are going to have 5 times square root of 5 times 25. That gives me 5 root 5, and that's going to be in centimeters. Now let us check. Oh, we got to give it in 3 significant figures. Now in that case, if you are going to work out 3 significant figures, it will be 11.2 centimeters. So that's the answer to 3 significant figures. Okay. Now number 2. We have got this time round a cube. A cube has, well, all the length will be 9 centimeters in that case, and the length of the diagonal. Now, I did mention I was going to use a shortcut. Now, we're going to apply this shortcut in that case for question 1. So the shortcut is as follows. So if this is x, that's y, and this is z. Okay, so 3D Pythagoras. So if you wanted to get this answer as a shortcut, you just have to do d squared equals x squared plus y squared plus z squared. And d, which is that length, so d equals the square root of, in fact, all the sides that you've been given. So you can call that x, y, and z. So we are going to get 8 squared plus 6 squared plus 5 squared, and the answer should be the same as 11.2 centimeters. Now, it does not always, it does depend on the question about what you want to do, so be careful. Do not always just apply that formula and think, okay, you got the answer, but you got to be careful when you take shortcuts. Okay, so moving on to question 2 this time. So a cube. So let's draw the cube. Okay, so the cube. So we got a cube. I'm going to draw that at the bottom, and then I'm going to repeat the same shape at the top. And let's see if that makes a cube. Well, okay, quite close to a cube. So we got 9, 9, and 9 centimeters for all the sides. What it is asking me to do is find the length of a face diagonal to 3 significant figures. So face diagonal, it's not that distance we worked out earlier, which was right there. This one is a space diagonal, so across the whole space. But here we're only looking for one of the faces, so a face diagonal, that's what it is. So let us see what that means. So we are going to look at this face and draw it here. So it's 9 centimeters by 9 centimeters, and what we're looking for is a diagonal across this face. So okay, we also know that this is in centimeters, 9. Now if we call that A, B, and C, we're actually looking for length C. So C using Pythagoras theorem is going to be C squared equals A squared plus B squared. And after substitution, so that's 9 squared plus 9 squared, and C is the square root of all that, and that's going to give you 81 plus 81, so double 81, so 162, square root of 162, and the answer is 12.7. To 3 significant figures, and never forget the unit. because you might lose a mark for this. Okay, now hopefully you picked up some ideas from here, and now we're going to be looking at the next questions for you to practice, and that's going to be your turn now. Let's see how far you can go with those questions. Okay, so let's pause, do the questions, and move on when you finish. Okay, so concept number 3, elevation and depression. Now, in that case, the examiner's tip is as follows. Elevation and depression angles are always measured from the horizontal. Sketch the horizontal line first and then the line of sight. Oh, interesting. Line of sight. So we're going to see what that means in the questions we're going to be answering. So, of course, we're going to be drawing as well. So, from a point 50 meters from the base of a tower. Okay, so we got a tower, right? So let's do that tower as a line. So from the base 50 meters from a point 50 meters from the base of a tower. Okay, so let's draw 50 meters from that base of the tower. So we got another point there. So the angle of elevation to the top. So this is your elevation. We're looking upwards, and theta is going to be our angle of elevation. So that angle of elevation, well, we already know it is 38, so we might as well just replace theta by 38. So 38 degrees, let's write this down in that triangle. Okay, and we want to know the height. Now, the height is in fact the opposite. Okay, so now you may have recognized that already because you got an angle, so and a right angle triangle. So very quickly you will have spotted the idea of SOHCAHTOA. Now we are dealing with the opposite and the adjacent and the angle. So opposite, adjacent, and the angle. Okay, there's nowhere we're going to find hypotenuse being mentioned in that case. So we know we're going to be using TOA. So if you like formula triangles, you know what to do. Where is the question mark? So we're looking for the height, which is the opposite. So this is the opposite, which means we're going to be multiplying the adjacent with the tan. So opposite is adjacent multiplied by tan. Okay, so opposite is the elevation, so the height of the tower. All right, okay, use the word used by the examiner so they know what you're trying to do. And the adjacent is 50 multiplied by tan of 38 degrees. So 50 tan of 38, that gives you 39.1 meters. Okay, next question. From the top of a cliff, 80 meters high, so we're looking from the top, which is 80 meters high. So the angle of depression, so we're looking at, so our line of sight is towards the bottom. So we got a boat, let's call that boat B, which is just, let's say this is the sea level there, and we got B. And okay, we're assuming that is going to be a right angle triangle. So remember, you ought to be drawing a horizontal line. Okay, so remember, angle is measured from the horizontal, so that's 25 degrees below the horizontal. Okay, and you may remember that these two angles, so this angle and that angle, if you remember, they are equal angles because these are two angles called alternate angles between parallel lines. So alternate angles, if you remember that. So that's what we're going to apply. And using this idea, we can tell that 80 meters is representing the opposite. Okay, and what are we looking for? We're looking for the adjacent. So, all right, going back to SOHCAHTOA. Okay, let's eliminate the ones that we haven't been talking about at all. We have not talked about hypotenuse. So let's talk about TOA. Okay, TOA is going to help us work out the adjacent. And the adjacent is simply the opposite divided by tan. Now, adjacent is what is the horizontal distance. So let's write horizontal distance, and that is equal to the opposite, which is 80 divided by tan of 25. Okay, and that answer is going to be 171.6 meters, because that's what it gave us, 80 meters originally there. Okay, so that's the answer for question number 2. Now it's time for you to do some practice questions. You might want to just pause and see how I've done those 2 questions, and then when you're ready you can practice the questions on the right hand side. There you go. That's your turn to practice those questions. And yeah, pause the video, and we're going to be seeing you shortly on the next slide. Okay, here you have the answers, and I've highlighted some of the uh, sides for you to be able to see clearly which of the SOHCAHTOA you have to use. And the diagrams are always very important. Diagrams really stress the fact that you understand how to visualize what's on the question, and also make use of that visual aspect to be able to solve problems. Okay, next one is concept number 4. Here we're going to be combining trig methods. The examiner tip about this goes like this. Before starting, decide, is there a right angle? Are 2 sides and an angle known? And you have to sketch the triangle and mark what's known before choosing a method. Okay, so that's what we're going to do in this question. Now, a triangle ABC, this is what we got. AB is 12 centimeters, BC is 9 centimeters, and the angle between them is 65. So I can draw 12 centimeters here, and that's A and that's B, and that's the shorter distance, 9 centimeters, and the angle is at B, or the angle is at B, so let me double check. So AB is done correctly. Oh, okay, so BC, we haven't got BC, so therefore it's good to double check. Now, right, so what I could do in order to, so that's where eraser is handy. So let's do, so rub this off. So this is what you should be doing in exam. It's actually a fortunate mistake here. So we got BA as 12, doesn't change that distance, and therefore B and C are, so B is a common point to both sides. BC is 9 centimeters. Now I can draw my line from A to C. So it says ABC equals 65 degrees. Okay, so that's sometimes when you make mistake. It's good, learn from a mistake. Okay, so what we're looking for is to find AC. Now, in this case, we have to decide about the method that we're going to apply. Okay, it doesn't say that this is a right angled triangle, and it doesn't say it's not a right angle, definitely. So you can't use Pythagoras. you can't, therefore, let's see if you can use SOHCAHTOA. You can't as well, and the reason is because you haven't got a right angle triangle. So these are the reasonings you should be going through before you decide. So Pythagoras can't. So we're going to write Pythagoras. You can't. You can't use SOHCAHTOA as well. You can't do that. So therefore, we now think, okay, can we use the sine rule? Okay, sine rule requires sides. Okay, let us say we got that one. We need to work out the side of. We can't work out the side. There are two sides and one included angle. So that should be the cosine rule. Okay, so cosine rule is the one that's going to save the day. So cosine rule, what's the cosine rule saying? Now, before we actually start writing the formula, let's look at the side here. That's going to be a b lowercase c, because that's the opposite of angle C, and then lowercase a. Now, when you're going to write your formula for the side, so b squared, if we start with b, we'll end up with a capital B at the end. So now how about the other two letters? Okay, so a squared and c squared minus double AC, and then you're going to write cos before the angle B. So we're looking at cos B. Okay, so a squared, that's going to be 9 squared plus 12 squared minus double 9 and 8, 9, 9 and 12, and then cos of 65. Okay, so let's answer that question. So 81 plus 144 minus, okay, so 9, that's 18. So you can multiply this using your, it will be a calculator question anyway. So B equals, so now if I'm looking for B, I might want just to draw this square root over here, and the answer should be B. Remember, B is AC. That's what we're looking for, and that's going to give us 11.6 centimeters. Here we go. That's what we've been looking for. So you can see from this question, we tried all the different concepts. Pythagoras didn't work, SOHCAHTOA didn't work, sine rule didn't work. Now we got cosine rule. So it's just like trying to see which tool is going to be best for this job. Question 2. A flagpole stands on horizontal ground. So let's draw the flagpole on a horizontal ground. Okay. Now, from a point 20 meters from its base, okay, so 20 meters from the base of the flagpole. So let's say this is point A, point B, and 20 meters. Let's call that point C. Okay, and then we're looking upwards. That's why we use the idea of elevation to look at the flagpole. So from the base, the angle of elevation to the top. So angle, so looking to the top, so it will be that way. So 35 degrees. Okay, so now just find its height, elevation. So we're looking for this, which is just the opposite. Okay, we got the opposite to look for, and that is the adjacent, and that can be an angle, can be sine, cos, tan from a calculator. So if you remember, SOHCAHTOA, the one we have not mentioned anything about is the hypotenuse. Okay, so in that case, let's look for TOA. And what are we looking for then? Opposite. So opposite is going to be the subject. Opposite equals to the adjacent multiplied by tan. So opposite is length AB, or the elevation or the height, which is equal to the adjacent, which is 20 multiplied by tan of 35 degrees. So 20 times 5, tan of 35 degrees, that's going to give you three significant figures. That's 14.0 meters. Okay, so study those two different problems and see if you can apply these ideas on the question which will appear shortly, and that will be your turn to answer those three questions. So pause the video here and see if you can attempt those questions by yourself. Here are the answers. So you're going to be able to see different methods being applied in those three questions. Okay, hopefully you got them right. Now, let's look at what we've learned so far. So key takeaways from trigonometry part 2 exam style practice. Firstly, you will have picked up that we have to draw a label diagram for every bearings 3D elevation or depression question before calculating anything. You will have picked up that you redraw 3D right angle triangles as flat 2D diagrams to avoid errors. Is for more clarity. Elevation and depression angles are equal between 2 points by alternate angles. So if you remember, we've seen alternate angles in one of the cases. Multi-part questions often need two trigonometric methods used in sequence, and we have had the opportunity to decide from 4 scenarios which one was the most appropriate. Coming up in part 3, extended problem solving, multi-step grade 9 challenges combining trigonometry with hidden right angle triangles, combined sine and cosine rule problems, and proof style reasoning. I hope you enjoyed this video. Please like, share, subscribe, and comment. Your feedback will help me create more videos like this. I'll see you soon in another video. Thank you. Goodbye.